Today's topic is geometric construction, and what you will need is a straight edge, a set of dividers, and a pencil. This is the index of what I am about to demo. 28 different sketches. The first sketch is how to sketch a 60-degree angle. Let's start by drawing a horizontal line. I'm drawing mine about 4 inches, but you can make yours shorter or longer depending on the piece of paper you have. Take a set of dividers from A to B. Strike your arc upwards, and with A as center, strike an arc. Let's call this one C. That's 60 degrees. Now take a straight edge and go from B through the intersecting point, and you just drew a 60-degree angle. The next one is how to develop a 30-degree. I will be doing A to B for this exercise 4 inches long for all of them. Again, that's 60. Now, my intent here is to bisect the 60. This one's a bit more frustrating. It's how to find a 45-degree with this method. It's called the trial and error method. First of all, I'll find my 60 again. And keep in mind, there are quicker ways, but we know that one's 60. So basically, I want to try and find every 15 degrees using the trial and error method. So I made my dividers a bit smaller. And you can see I'm still short of the 60. Readjust the dividers. I'm aiming for 4 shots to hit the 60-degree mark. So I'm very close. So I'm just going to make a minor adjustment, add to it. And there it is. So each one of those last marks is 15 degrees. Which makes 3 marks at 45. The next one is we want to develop a cheek pattern for a 60-degree elbow. This little exercise is almost identical to the first sketch we drew. 60 degrees, and in the HVAC world, or the sheet metal world, an elbow cheek resembles this is a throat. The next one we're going to do is a frustum of a cone. A frustum of a cone is basically part of a cone. Again, I drew a base of 4 inches, found midway point. Using your dividers, strike an arc from A and B. Bring this line down to the center of A and B, which is perpendicular. And call this C. Now choose any dimension. I'm just choosing a smaller dimension here, roughly an inch. Make a mark up and down. So now set your dividers to approximately 2 or 3 inches. And from 1, strike 2 arcs, and from 2, strike down. Now with your straight edge, connect these intersecting points. And now with a frustum, the top should be smaller than the bottom. So I just picked any dimension as long as it's smaller than AB. Again, straight edge, finish the sides. You now constructed a frustum of a cone. The next one is how to construct a 90-degree cheek. This throat dimension can be any dimension at all. Now, here we're going to talk about a line that is tangent to a circle. Tangent simply means touching a circle at one point. So in this case, I'm drawing a 2-inch radius, which is a 4-inch diameter circle. Using the same radius, I struck an arc towards D. Same radius as I did for my circle. Now from D, set your dividers to approximately 1 inch or 1.5 inches. Strike an arc up and down and letter them E and F. Now with your dividers greater than half of D to E, or greater than D to E, set your dividers to approximately 2 inches. 2.5 inches. Your center point's on E. Now your center point's on F. Straight edge. Draw the line, and you will see that it is touching the outside of the circle at one point only. This one here is how to construct an eccentric circle. Eccentric circle simply means a circle that doesn't have the same center point. this case, I'm setting my dividers to 2 inches. I will draw a circle. And I'm going to locate, for this one, half of AC and draw another little circle, which will be a 2-inch circle, 2-inch diameter. Because my marker dividers they don't work well for this. This one here is how to construct an equilateral triangle. Draw a line A to B, set your dividers A to B, strike an arc upward from A and B, and connect using your straight edge. This one here is an acute triangle and an obtuse triangle. The one I am sketching right now is the obtuse triangle. So I draw a line A to B, which is 4 inches approximately. Now I'm going to set my dividers to greater than A to B and strike an arc outward. And if I was drawing an acute triangle, it would be shorter. And now, any distance at all, strike an arc, and you have now constructed a obtuse angle triangle, simply meaning one of the angles is greater than 90 degrees. This one here is how to construct the elevation view of a right cone. A right cone is basically a cone of any shape, as long as the center top is directly above the center of its base. I could pick any distance right now, but I've chosen this one to represent the right cone. The next one is how to make an arc through 3 given points. If you want to connect 3 points, this is the method to use. First of all, I'm going to bisect AB. And let's do the same for BC. With your straight edge, go through the intersecting points. And you will determine where the bisectors meet. They meet at D. Now with your dividers set to D, or the center point at D, go to any one, A, B, or C, and they should connect. The radius should go through all 3. The next one is how to construct a scalene triangle. First of all, let's start by drawing a 4-inch line. Again, these lines do not have to be 4-inch. They need to be AB. Now set your dividers less than AB, strike an arc upward. And then reduce the dividers again and strike an arc within that other arc. And just call this C. And you've now drafted your scalene triangle. Concentric circles. This simply means two circles having the same common center. This one here is how to construct another line parallel to a given line. So how to construct parallel line. If this is your given line AB, set your dividers to any distance, and at approximately A, strike an arc upward. Do the same thing for approximately near B. And what you want to do is draw a line tangent to these two arcs. Again, tangent means touching an arc at one point only. The next one, we're going to construct a round corner. So let's say we have a perpendicular corner. But we don't like the sharpness of perpendicular, so we're going to create a round corner. So A to B and A to C are the same distance. Now you can pick any distance depending on how round, what radius of a corner you want. Now, don't touch, leave your radius set to the same distance, AD, and swing from E, swing from D to find your intersecting point, which is F. And now with F as your center, this becomes your corner, roundish radius corner. Now we're going to construct an octagon inside a circle. So right now I'm bisecting. I could have measured it with a ruler, which I did, but this is bisecting a line. So once your bisectors are there, you can draw a line straight down. Set your dividers from C to B or AC and scribe your circle. With radius CB, strike an arc outward for all 4 quadrants. Again, with your straight edge, connect the dots on the outside circle. In this sketch, we're going to build a hexagon inside a circle. First of all, let's draw a straight line with a radius point in approximately the center. Now, with your dividers set with a radius, scribe your circle. Now remember that your radius is equal to 60 degrees. Now all I have to do is use a straight edge and connect those intersecting points to finish the hexagon. This sketch, we are going to inscribe a pentagon inside a circle using the trial and error method. Scribe an approximate line with a radius point near the center. Set your dividers from C to A. Draw a circle. Now again, I said earlier, it's trial and error. So right now I'm just picking a random radius. And my goal is to walk along the circumference of the circle 5 times and stopping at A. And here you can see my radius was set too large. So reduce the radius. This time looks a little short. So just a hair longer than that one, and we should be fairly close. 3, 4, and 5. That's close enough for the pentagon by trial and error. Now we're going to inscribe an equilateral triangle inside a circle. Start by doing the same thing. A line with a dot near the center, or a radius point. Draw your circle. And we're going to use the same method. This is 60 degrees. The radius point is equal to 60 degrees. So instead of 6 sides of a hexagon, we've got 3 sides for an equilateral triangle. Now let's draw an arc through 2 points. Sketch a random line, call it AB. Do as if you were bisecting AB with the same radius. You are able to strike through A and B. The next one is to construct a perpendicular line on a given line. So here I'm drawing a line about 4 inches long. And let's say at this point, C, I want to erect a perpendicular line vertically. Set my dividers from A to C. Inscribe an arc. And where it touches line AB, call it D. Now I would recommend a radius larger. Strike an arc from A and D upward to establish point E. And from point E to point C, connect or draw a straight line, and you will notice you are 90 degrees, which is perpendicular. Here we're going to bisect a 90-degree or right angle. Draw a 90-degree with your dividers with any measurement. Strike an arc upward, call it B and C. With the same radius and B as center, strike an arc outward, C as center, strike an arc. And simply connect through the intersection, and you have now bisected your 90-degree angle. This one we are going to draw a square inside a circle. Here I'm drawing the same horizontal line, A to B, approximately, for me, approximately 4 inches long. And now I'm going to bisect AB. Now I'm setting my dividers from C to B or A to C and drawing a circle. And now I have 4 points on the circle. Simply connect and you've got your square inside a circle. This one here, we are going to divide a half circle, or called a profile, into 6 equal spaces. First thing, I'm going to draw a horizontal line approximately 4 inches long with my center, and I'll call this A, B, and C. With my dividers set from C to B or C to A, sketch the half circle. And here I'm simply drawing a vertical line from C up to the profile. with the dividers set from C to A, which is 60 degrees, strike an arc up and down to get you 30, 60, 90. That's 30, 60, 90 degrees. Now I have 6 spaces. How do we find out how long that circumference is, or the perimeter of that profile? Is by simply setting your dividers from one of these spaces, and they should be very close to being identical. So all I got to do is step it off 6 times to find the length, to physically find the length from 1 to 7, which is called a stretch out or half circumference. Now I'm going to use the slant rule method to divide a line into equal spaces. Let me start by drawing a line. And let's say we want to divide this line into 5 equal spaces. It can be any number of spaces, but I've just chosen 5. Take your ruler, set it up at 0 in the bottom corner, and find a number that divides well into 5 by 5. And I use 15. So I got 15, so I'm going to be making a dot at every 3 inches. 3, 6, 9, 12. And from those dots, you come down vertically to your baseline. And we often do this in sheet metal for 12 equal spaces for most of our parallel line fittings. So here I'll quickly do 12 equal spaces. Because my sheet wasn't long enough, I will divide this in 2 or bisect it and treat each half side into 6 equal spaces. Using the slant rule, start off at 0, and I'm using 6 inches as my slant, and I am making a mark at every inch. 0, 6, and make a punch mark at every inch. Now you want to draw vertical lines up through those points. This is very common for those of us who need to physically lay out patterns for parallel line development in the sheet metal trade.